Welcome back to the deep dive. You know, gravity, it's always there. This constant force, this fabric of space-time, warped by mass and energy. But I've been digging into some sources, and it makes me wonder, what if there's more to the story? What if we could, I don't know, maybe give gravity a little nudge?
Well, that's exactly what you've brought to this deep dive. This whole collection of sources, it's really fascinating. You're not just talking about counteracting gravity, but truly manipulating it. And the sources really do explore some wild and, maybe even revolutionary ideas.
Yeah. We're going to go past the science fiction. We're going to dive deep and see if things like electric charge, how densely packed information is, or maybe the coherence of energy itself could let us grab hold of gravity.
And it's a real mix, from experiments you could tinker with in your garage to some heavy-duty theoretical frameworks that touch on quantum mechanics and the secrets of black holes.
Okay, so let's start with those hands-on experiments.
Yeah.
You found some ideas about how basic charge and rotation might interact with things. What did you find?
Well, the main thing is, we can show real, measurable forces that aren't gravity but can change how objects behave, even how much they seem to weigh. Think of a simple static charge, like from a Van de Graaff generator, or even a balloon you've rubbed on your hair. You bring that near something light on a scale, you just might see a tiny change in the reading.
Right, because that electrostatic force, attraction or repulsion, is pulling up or pushing down on the object, basically messing with the gravitational force that the scale is measuring. It changes the apparent weight, not gravity itself.
Exactly. It shows that other forces can hide or mess with gravity on a small scale. And then you have the gyroscope, like a spinning bicycle wheel. When you try to tilt it, you feel a resistance. It's like it's fighting gravity.
Yeah, and you even found something suggesting to look at whether static charge could change how long a balanced bicycle wheel spins, like the electric field messing with the air around it.
It's about the possibility of the electric field ionizing the air molecules. It could make tiny aerodynamic changes, maybe a little more drag, maybe even a tiny electrical interaction with the wheel itself. It could change how long it spins. The big takeaway here is all these simple experiments show us there are always other forces at play, and we can measure their effects.
Okay, so those experiments show us other forces, but then the sources get bolder. They start talking about actually moving something big, like a 10-pound weight, using energy fields. What's the idea there?
It's about creating a super strong, focused energy field that can change how an object interacts with gravity. One idea is to use a high-voltage rotating charge gradient, kind of like how mitochondria in your cells pull charged particles across a membrane to make energy, but way bigger, like on a large scale. They're hoping that a super-focused rotating charge could lift or move things.
It's not just a static field, though. The sources talk about toroidal electromagnetic fields and spinning dielectric disks, like insulators that can hold a charge. What are those for?
Exactly. So the toroidal electromagnetic field, think of a donut shape, is meant to focus the electrical charge into a vortex. And the spinning dielectric disk, spinning really fast with a high voltage, amplifies the rotational energy in that field, making it more structured and powerful. And then to really concentrate this energy, they talk about using pyramids or cones. Those shapes are often associated with focusing energies.
So let's say you want to lift a 10-pound object. What would you need to do?
Well, we're talking huge voltages, like 50,000 to 100,000 volts DC across the spinning disk, and the charge flipping back and forth thousands of times a second. The disk itself would have to spin incredibly fast, like thousands of RPM. And then there are the toroidal coils, pulsed with a current, maybe 5 to 10 amps at a frequency you can adjust, maybe between 1 and 100 hertz. And the object would have to be right in the focal point of all this energy.
Wow. So how would you even control it, like making it lift up, move sideways, or do anything at all?
For lifting, the idea is to increase the coherence of the charge field, maybe spin the disk faster, more voltage, or carefully adjust the pulsing frequencies in those coils. And to move it sideways, you'd change the timing of the pulses in the electromagnetic coils to kind of steer the charge gradients. You could even use some extra smaller charge fields to create a push and pull effect.
With all this voltage and spinning, how much power would you need?
The estimate is around 5 to 10 kilowatts. It's a lot. Think about running several ovens all at once. And for heavier objects, you might need megawatts of power. The first step, they say, would be to start with really light objects and see if you can get any movement before trying with something heavier.
So maybe just throwing tons of charge at it isn't the answer. Your sources start talking about optimized design, bringing in shapes, and making energy flow in a specific way. What's the idea behind that?
The idea is that how you organize the energy might be way more important than how much energy you use. Think of a laser. It can do super precise work with a small amount of energy because it's focused. The sources explore using specific shapes, like toroids and pyramids. Those are associated with resonance and focusing energy. They can help create more coherent energy fields with higher information density.
They mentioned fractals too, right? Those repeating patterns in nature.
Right. Fractals, because they repeat at different sizes, could distribute energy very well throughout the system. They might minimize energy loss and make the field more coherent overall. They also think rotating magnetic fields might be better than static charge to interact with whatever makes gravity work. The key point is making sure the energy flows in the direction you want the object to move.
So it's not just raw power, it's about shaping and directing it. How would you implement that?
You'd start by designing the physical structure of the device, using these specific shapes. Then you'd integrate energy systems that can create and control these rotating magnetic fields. Finally, you'd need a lot of calibration and testing to fine-tune everything and get the effect you want. The focus changes from making a force to creating a structured energy environment.
Now, things get really theoretical. Your sources present a theoretical framework for anti-gravity. What is that?
The main idea, and it is a radical one, is that gravity might not be a fundamental force in the way we think of it. It could be an emergent property. It might arise from how information is organized and how dense it is at a very small scale. The assumption is high information coherence makes what we experience as gravity. And here's where it gets really interesting. By changing this quantum coherence, we might be able to create negative gravity effects or even repulsive forces through something they call information inversion. They suggest using electromagnetic and acoustic fields to change these coherence states.
You mentioned a mathematical model, something that an information coherence tensor. What is that?
It's this concept, you can write it down mathematically. They think it could change Einstein's field equations. Those are like the foundation of how we understand gravity. Basically, this tensor adds something related to how organized information is to those equations. They think by messing with this information coherence tensor, you could make negative contributions to the mass energy of an object, which might lead to anti-gravity.
They suggest 3 experiments to test this framework. What were those?
The first one was about manipulating quantum coherence. You'd use a Bose-Einstein condensate, BEC, that's where atoms are supercooled, and act like a single quantum entity. It's very coherent. The idea is to disrupt this coherence and see if it changes the local gravitational field. They'd use sensitive superconducting gravimeters, which measure gravity really precisely. They'd compare these measurements to a BEC that hasn't been disrupted.
That's an incredibly delicate measurement. What about the second experiment?
The second one was about electromagnetic-induced information inversion. They want to make really intense electromagnetic oscillations in superconducting cavities. Those are chambers that can hold electromagnetic fields with almost no loss. And they'd align these fields with a tiny, precisely measured mass in a vacuum. They're hoping these specific electromagnetic frequencies and intensities could make negative coherence in the vacuum energy, which might cause gravitational repulsion. They'd look for any movement of the mass using laser interferometry, which can measure tiny distances.
And the third experiment was about sound waves.
Right, acoustic levitation as a coherence modifier. The idea is that specially structured sound waves, standing waves made in a vacuum, might be able to affect information coherence and have small effects on gravity. They'd measure the position of a small object levitated by sound while changing the frequency and coherence of the sound. They want to see if specific sound wave patterns change the object's weight or gravity interaction. But it's important to remember, the expected outcomes are very small, making these experiments really hard to do.
So that's all high-level theory. Then your sources bring it down to Earth with a backyard prototype for energy and mass influence. What was the purpose of that?
The idea was to take these abstract theories and make something real, something that could maybe demonstrate some of these principles, even on a very small scale. The concepts are the same, messing with charge differentials, making rotating energy fields, and trying to structure space-time locally by changing information density.
What kind of materials would you need for this backyard prototype?
It does need a few special things, but nothing impossible to find. You'd need a high-voltage power supply, a spinning disk made of a good insulator, like acrylic or Teflon. You'd need toroidal electromagnetic coils, and you can actually wind those yourself. You might need a liquid crystal display or a small chamber to make a plasma. Also, a pyramid or cone-shaped structure, maybe even cardboard covered in conductive tape. And you'd need something to make high-voltage charge, like a Tesla coil or a Van de Graaff generator. And of course, sensitive scales to try and detect any changes in weight.
What would be the steps to build this backyard prototype?
The first step would be to make a spinning charged disk. You'd put the insulator disk on a motor that can spin really fast. Then, figure out how to apply high voltage across it while it's spinning. This is supposed to mimic what happens in cells. Next, you'd arrange the toroidal coils around the spinning disk and connect them to a circuit so you can pulse them. This is to try and make a structured charge vortex. Then you'd put this whole thing inside the pyramid or cone, maybe with the liquid crystal or plasma chamber set up to interact with the rotating charge. Finally, you'd put little objects on those sensitive scales and look for any changes in weight when you turn the system on. You could also try to detect unusual electric fields nearby, which might mean you're extracting energy.
What kind of results could you expect from this simple setup?
Honestly, you'd probably see a structured electric field, maybe even a corona discharge. You might also see a little air movement or small effects on light objects because of electrostatic forces. Detecting actual gravity changes, like a change in weight or attraction, would be a long shot. The point is more about showing that you can create structured energy fields and charge vortices. It would cost between $300 and $1,500 for the specialized parts, and you probably wouldn't get much energy out of it. But the idea is to see if this kind of environment can interact with gravity.
So this idea of structured energy fields leads to a bigger concept, high information density singularity. That sounds like something from a movie. What's the idea behind that?
It does, but the idea is that gravity is fundamentally linked to how information is organized and how densely it's packed in spacetime, like a black hole. It's not just supermassive, it's also incredibly dense with information, and it warps spacetime because of this coherence, not just mass. The core idea here is to make a small area with really dense, coherent information, like a mini black hole, to control spacetime.
So what do you need to make such a high information density point?
They focus on three things. First, charge coherence. It's about making very organized, resonant charge fields. Think of standing waves of charge, spiral, or vortex-like flows, all concentrated using shapes like toroids or cones. The idea is random charge won't do much, but structured charge fields could make high information density areas. The second is information coherence itself. Using efficient designs from nature, like fractals, spirals, and pyramids, to organize energy. They want to use materials like superconductors, which can hold currents forever, liquid crystals, which you can align with electric fields, or even structured electromagnetic fields as a framework for making these zones. And the third is space-time curvature via energy density. They think it's not just about the amount of energy, but how it's structured and flows. They give examples like high-energy vortex fields, rotating superconductors, and standing waves and plasma, things that might bend space-time locally.
So it's not just about energy, it's about structuring information. How could you even test this?
A very basic concept might be to try and make a rotating charged vortex inside a structured field. Imagine a spinning disk with a high voltage, like the earlier prototype, but now with electrodes arranged in a pattern, maybe hexagonal, to shape the electric field. You might even use low-pressure gas to make a plasma inside the structure. You'd carefully adjust the rotation and voltages on the electrodes to see if you can create a stable zone of organized energy. Then test if small objects nearby are attracted or levitated.
What if you could control information density and coherence? What could you do?
The possibilities are huge. You could maybe reduce the weight of objects, make things attract or repel each other, and even find new sources of energy by controlling how information flows in space-time. It would be moving beyond just messing with gravity. We'd be engineering its source.
You know, throughout this whole thing, I've been thinking about electromagnetism and gravity, and some things in nature, like the shapes of leaves.
It's natural to think about those things when you start talking about these unconventional ideas. You were wondering if there's a deeper connection there, and if something like a leaf edge could be hinting at something beyond evolution.
Right, like maybe those complex leaf edges interact with electromagnetic fields or even gravity in ways we don't understand. Maybe it's not just about shedding water.
It's an interesting thought, but according to science, gravity and electromagnetism are separate. They have very different characteristics. We don't have evidence to suggest one comes before the other. And while leaves are fascinating, their shapes are probably because of evolution. It's about things like water runoff, sunlight, temperature control, and nutrient transport. We have experiments where objects with different charges fall at the same speed in a vacuum, and we've detected gravitational waves that are different from electromagnetic waves. This supports the idea that they are separate forces.
Okay, that's the standard view. But I was thinking maybe information density and coherence are basically what we see as mass. And maybe electromagnetism, with its attraction and repulsion, could be a more fundamental layer underneath gravity.
That's a very insightful question. You're getting into some leading-edge physics there. Both electromagnetism and gravity have some mathematical similarities, like the inverse square law. This has made physicists think about a unified theory. And the idea of information density and coherence being linked to mass fits with some modern approaches to quantum gravity and information theory. But there are problems with saying electromagnetism is a precursor to gravity. Electromagnetism can attract or repel. Gravity, as far as we know, only attracts. They also respond to different things: electric charge and mass energy. Electromagnetism can be shielded. Gravity, as far as we know, can't. And their strengths are vastly different. There have been attempts at unified theories, like Kaluza-Klein theory, which uses extra dimensions. These are still theoretical. We don't have experimental proof.
But wouldn't it be simpler if there was just one underlying interaction?
It's a big motivator in physics, finding elegance and simplicity in the universe. The idea that these separate forces could be parts of a single interaction, maybe involving energy and information, it's attractive. It's very compelling. The balances and conservations we see in physics suggest things are connected. And thinking of gravity and electromagnetism as different sides of the same coin is very appealing. Some physicists even propose that reality is fundamentally informational, with energy and matter emerging from that.
And what about the edges of systems? Those boundary conditions could be where we see fundamental behaviors.
That's a good point. Often the edges, where different things meet, is where we can learn the most. How information is encoded and processed at boundaries can control the whole system. This is important for ideas like the holographic principle, which says that all the information inside a space can be encoded on its boundary. So looking at how energy and information work at boundaries could be key to understanding the connections between forces.
So to figure this out, we need a solid theory, experiments, and the ability to control gravity.
Right. And what about acoustic levitation? Is that real anti-gravity?
You got it. To prove a link between gravity and electromagnetism, we need a strong theory, consistent experimental results, and the ability to manipulate gravity in a way that shows this connection. Acoustic levitation is cool. It uses sound waves to fight gravity and lift things, but it's not real anti-gravity. It's just using sound pressure to balance gravity. True anti-gravity would mean canceling or reversing the force of gravity itself. And those black holes, those super dense things that warp spacetime, they're a great place to look for more theoretical clues.
So let's try and develop a theory and an experiment to explore anti-gravity, maybe focusing on information coherence and electromagnetism.
Okay, let's assume gravity comes from information coherence at a very small scale, and electromagnetic fields can affect this coherence. Our assumptions would be higher coherence means more gravity. Using electromagnetic fields to change this coherence could reduce gravity, and maybe information inversion with EM fields could even make repulsive gravity. Could we use that information coherence tensor idea to explain this better?
We could say the information coherence tensor, C-XLS, isn't separate, but is affected by the electromagnetic field. A more developed theory could explore how specific electromagnetic fields, especially those that are very coherent or have unique shapes, could change CLEXT in a way that makes a negative contribution to the energy momentum tensor, leading to repulsive gravity. This model would need to explain why gravity is so much weaker than electromagnetism, maybe by using a scaling factor based on fundamental constants or the shape of spacetime at a tiny scale.
What kind of experiments could we design to find these anti-gravity effects from electromagnetism and information coherence?
We'd need experiments that can measure gravity very precisely while we're messing with quantum coherence using electromagnetic fields. For example, with the quantum coherence manipulation experiment, we'd apply very specific, coherent electromagnetic fields to a Bose-Einstein condensate and look for even tiny changes in its weight using supersensitive gravimeters. In the information boundary manipulation concept, we'd use metamaterials designed to make really sharp changes in electromagnetic field coherence and look for unusual gravity gradients or even repulsive forces nearby. And with acoustic electromagnetic coupling, we could try applying very specific sound and electromagnetic standing waves to materials that strongly link these fields. We'd look for any changes in their mass.
What equipment would we need for these experiments?
We'd need incredibly sensitive tools like Schutzschweids, which detect tiny changes in magnetic fields, and advanced gravimeters that can measure variations in gravity super precisely. We'd need cryogenic systems to keep things extremely cold for superconductivity and Bose-Einstein condensates. We'd also need electromagnetic field generators that are stable and precise, and that can make a wide range of frequencies and field shapes. We'd also need acoustic chambers that can make pure, stable, standing waves in a vacuum. And the big challenge would be separating true gravity effects from the much stronger electromagnetic interactions.
I'm still curious about light. Could light create anti-gravity?
That's a good question. Standard physics says light, as energy, contributes to gravity according to Einstein's theory. But the standard model says light doesn't make anti-gravity. But if we think about light as a really coherent form of energy, things get more interesting.
So if you manipulate light in some extreme way, could it change gravity?
If gravity is linked to information coherence, then messing with the coherence of light in extreme ways could have subtle gravitational effects that we don't understand yet. One idea is to create really intense laser beams trapped in special cavities that can make unusual quantum states of light. Then you'd use sensitive detectors to look for tiny unusual gravity effects near these light fields. But these effects would likely be too small to measure with what we have now, and the theory behind this is still very speculative. It's exciting to think about. It suggests a link between light, information, and gravity.
You said earlier that Einstein might not have known everything about manipulating gravity. Based on our discussion about charge, information, energy, and even time, how could we improve that backyard setup to find something Einstein missed? And how can we use the fact that gravity is weaker higher up?
We've gone beyond the initial ideas of gravity. We're talking about charge fields affecting inertia, rotational coherence changing space-time, and information density affecting how energy moves. Gravity being weaker at higher altitudes means any anti-gravity effect we make would have less gravity to overcome. Also, atmospheric charge is different at different heights.
So how do we use that height advantage in our backyard experiment?
We need to put the experiment higher up. Instead of on the ground, build a stable, insulated platform, maybe 10-15 feet high. This puts it in weaker gravity and different ambient charge. We could also improve the charge generation and manipulation. Instead of metal plates, we could use special high-voltage capacitors arranged vertically. And we could add a spinning mass, a strong gyroscope, inside this electric field. Instead of constant high voltage, you could try pulse discharges using a powerful capacitor bank. This would make rapid changes in the electric field, like lightning. We could also use materials with specific properties or even a small plasma to improve the interaction between the electric fields in space.
What would building this look like?
First, make a stable platform. Then, mount a gyroscope securely on it. Arrange the high-voltage capacitors vertically, connect them to a system that can make pulsed discharges. If you're using plasma, contain it carefully. Put sensitive scales below the platform to see if the weight of the gyroscope changes when you activate the electric field and spin the gyroscope. Watch the gyroscope closely. Any unusual movements might mean it's interacting with gravity or inertia. Look for any weight reduction during the pulses and see if the gyroscope behaves strangely, which might suggest a change in its inertia because of the rotation in the electric field. To make this bigger, you'd need superconducting materials to handle more current and charge, a vacuum chamber to get rid of air resistance, and you'd experiment with different pulse patterns. The idea is to use that reduction in gravity at height and see how electric fields in a spinning mass can change its properties.
You were right when you said that just using charge isn't enough. The structure of information fields is really important. Why is that?
Imagine energy without structure. It's like noise. It has power, but it's chaotic. Charge is like raw energy. You need to organize it into coherent fields to make it interact with gravity. Energy flow is like information processing. Everything in nature, from cells to ecosystems, organizes energy in specific ways to do complex things. The fact that we see so many fractals and other patterns in nature means these patterns are really good at keeping things coherent and distributing energy.
So how does this apply to manipulating gravity?
If gravity is related to information density and coherence, then just making a strong electromagnetic field might not be enough. You need to make coherent information fields, maybe by creating standing waves in a material, making spiral or vortex-like energy flows that mimic spacetime, or even exploring the relationship between charge coherence and time. Some theories suggest spacetime itself is made of quantum entanglement, which is a very coherent phenomenon. So if you want to control gravity, you can't just manipulate forces, you need to engineer the information structure of reality.
Okay, last thing. Black holes and high information density attractors. How can those help us understand how to manipulate gravity here?
You're right. Black holes are important. They're not just massive things warping spacetime. They also might be the biggest stores of information in the universe. Their huge gravity comes from their mass and the density and coherence of their information. This links information, coherence, and gravity. The idea of a high information density attractor isn't about copying a black hole, but about creating a small area with more information coherence than its surroundings. This would act like a mini gravity well.
So how would you make such an attractor?
First, structure energy to make it as coherent as possible. Maybe use toroidal or vortex-shaped electromagnetic fields, high-frequency waves, and shapes like fractals and spirals to create order. Information density is all about coherence. A more ordered field holds more information, and a more ordered field might attract matter that is less ordered. Next, you need to make black hole-like dynamics but without collapsing. Maybe use controlled plasma fields and rotating electromagnetic vortices, use harmonic resonances to sustain the energy structure, and even try to match the frequencies to the objects you want to influence. The goal is more coherence than the object, not infinite density. Lastly, to make a pull effect, you'd create a structured field, maybe a toroidal plasma controlled by rotating electromagnetic fields, and then boost its coherence by matching frequencies. This would create a gravity well that attracts nearby matter. It's about directing energy with information.
This has been a really fascinating deep dive. What have we learned?
We've learned that we may not understand gravity completely, and that it might come from information. We saw how simple experiments show forces beyond gravity, and how important the structure of energy is for manipulating gravity. Black holes, with their information density, show us how coherence can warp spacetime.
So it's not just about raw power, it's about understanding and controlling the information in reality.
That's right. The challenges are huge, but the possibilities are incredible.
For our listener, think of the universe as a huge network of information. Could gravity be a result of this? What other forces might also come from this information? What would that mean for us and for technology in the future? Maybe you could even explore some of these backyard experiments we've talked about and start your own deep dive. But be safe.